Hello and welcome to CLR 450, Clinical Data Management. My name is Linda Shostak and I am your instructor for this course. I am the Senior Director of Clinical Data Management for INC Research, and I have over 14 years of industry experience, including data management, project management, and quality control. I'm really excited about teaching this course and look forward to interacting with you. Please, at any point, if you have questions, email me and reach out to me. I'm happy to respond and give you feedback and work with you. The objective of this course is to provide you with an overview of data management as it relates to clinical trials. We'll be using Suzanne Proshka's Practical Guide to Data Management. Make sure you get the third edition. The second edition does not include information on electronic data capture or EDC systems. The course will consist of 12 1- to 2-week modules. Each module will start with a PowerPoint lecture that will give you a broad overview of the topics we're covering, and then you'll also have assigned readings in the text, as well as readings in additional sources such as the FDA and ICH regulations or scholarly articles. In addition, starting in Module 4, we're going to be performing hands-on data management tasks in UNCW's REDCap database. REDCap is an electronic data capture system developed and licensed by Vanderbilt University. You'll be using REDCap on UNCW servers. You don't need to purchase or download any additional software. We'll talk more about REDCap as we get closer to Module 4. This module is going to provide you with some basic information about clinical data management. You'll learn what the term clinical data management means, and you'll learn the most common types of clinical data management systems or databases. We'll also discuss the concept of quality data, and we'll cover common data management tasks, roles, and responsibilities. By the end of this module, you should have a solid understanding of the life cycle of a typical data management project. So, what is clinical data management? Our textbook states that clinical data management is the work performed on data from a clinical trial, from the preparation to collect that data through the time it's extracted for final analysis. Clinical data encompasses all the data generated by and related to the conduct of a clinical trial. Examples of clinical data include medical history, vital signs, physical exam, laboratory data, and adverse event data. The goal of clinical data management is to produce complete, reliable data that can be used to answer the question posed in the protocol. The clinical data management team is responsible for ensuring that clinical trial data are integrated into a format that can support the analysis. Regulations govern what we do. All data management activities have to comply with the general standards of good clinical practice. But in addition, there are a few regulations and guidance documents that specifically address clinical data management activities. One that you're going to hear very frequently is 21 CFR Part 11, and CFR stands for the Code of Federal Regulations. This documents FDA regulations governing electronic data records and electronic signatures. 21 Part 11 tells us that we have to validate databases to ensure they're accurate and reliable, that we have to control access to them, and that we have to have a computer-generated audit trail that documents the creation, modification, or deletion of electronic records. Now remember, 21 Part 11 is a regulation. This means compliance with it is required, not just suggested. There are also several guidance documents that we're going to have you read over. One is the Guidance for Industry in relation to electronic source data and clinical investigations. Another is the Guidance for Industry Computerized Systems used in clinical trials. And then we also have the ICH GCP Guidance E6. Section 5.51 through 5.512 relates directly to clinical data management activities. There are some other places where we look for best practice. One of these is the Society for Clinical Data Management, or SCDM. This is an international association of clinical data managers. The group focuses on best practices and has produced several documents defining their view of good clinical data management practices, or GCDMP. Copies of these documents are free to members, and the annual student membership due is $50 if you're interested. I can tell you that your text relies very heavily on the SCDM best practice documents, so you'll get a lot of coverage there as well. Let's talk about what a clinical data management system is. You'll also see this with the acronym CDMS. So a clinical data management system, or CDMS, is simply a computer system developed for and used to manage the data produced during a clinical trial. There are two primary types of systems. One is paper-based and the other is electronic data capture, or EDC. Paper-based CDM systems are designed around the use of paper or hard copy case report forms, or CRFs. EDC systems are designed to allow direct entry into a database and don't always use a paper case report form. Remember that the FDA defines a computerized system as a computer hardware, software, or associated documents that create, modify, maintain, archive, retrieve, or transmit digital information related to the conduct of a clinical trial. So this means that CDMS systems have to comply with 21 CFR Part 11, and that the industry was going to expect voluntary compliance with the ICH and FDA guidance documents as well. They're just considered best practice. So what else do we have to deal with a clinical data management system? Well, you're going to need to make certain that it is validated. The FDA defines validation as establishing evidence which provides a high degree of assurance that a specific process is going to work, essentially. This means that CDMS systems used for clinical trials have to undergo a rigorous process of testing to confirm that they do what they are designed to do. We're not going to cover the details of validation in this course, but if you want to explore it a little more in depth, I suggest you read Chapter 23, System Validation, Chapter 24, Test Procedures, or Chapter 25, Change Control, in your textbook. We have to have an audit trail. The FDA defines an audit trail as a secure, computer-generated, time-stamped electronic record that allows the reconstruction of the course of events relating to the creation, modification, and deletion of an electronic record. So essentially, all of your systems should automatically generate a record of who did what in the database. And over here I have a little example of the audit trail that is generated by REDCap, the system we'll be using. What functions do you find in the CDMS system? Well, most of them support the following functions: database design, entry screen production, data entry, data cleaning, discrepancy management, and query resolution. They also allow you to lock the data, import and export it, and they make an audit trail. So what's the difference between an EDC or a paper-based system? Well, remember that the EDC systems were designed to allow study coordinators or study site staff to enter the patient data right at the site. So EDC systems generally have limited document tracking capability, but strong point of entry checks for data validity. The site can enter the patient data directly into the ED system, or they may record the information on a source document or a paper case report form before they enter it. Paper-based systems were designed to manage paper copies of CRFs. The clinical site would record the data on a paper case report form. It'd be sent to a central data management group, which then entered it all into the database. Paper systems simply, they tend to have really robust document control and page tracking features, and then they also support entry, verification, data review, and all of those other capabilities. There are a couple of common or really well-known commercial systems. Most organizations are going to use a commercial system when they bought off the shelf and not when they wrote themselves. So they are pretty much purchasing the software like you'd purchase Microsoft Word. A really very small number of organizations build their own systems, and those are referred to as proprietary systems. Validating a proprietary system requires an enormous effort, so most organizations just purchase a commercial system and get going. Here are some of the more commonly known systems. For EDC, there's Oracle Clinical's Remote Data Capture System, Inform, Metadata Rave, OpenClinica, and RedCap. The paper-based systems, really the leaders in the industry are Oracle Clinical and ClinTrial. So how do we know what quality data is? There's no regulatory definition of quality data. In general, the drug development industry expects that quality data is going to be fit for purpose, it's going to be complete, it's going to be valid, and it will have an acceptable error rate. Fit for purpose means the data can be used in the analysis and decision-making process. You have the data you need to make the decision. In other words, that data is going to allow you to answer the questions outlined in the protocol. Data is considered complete if all the expected attributes of the data are present. For example, are all start and stop dates for an adverse event present in the database? Valid data is data that is correct and truly represents the values they're intended to measure or reflect. There's no regulatory definition for an acceptable error rate, but in general, the drug development industry considers an acceptable error rate to be between 0.1% and 0.5%, and that roughly means that you are finding 10 to 50 errors per 10,000 fields. I like this little graphic here. It was compiled by Dixon and Pierce, and it describes the characteristics of data quality in relation to auditing clinical trials. And I think it provides a really useful overview of the different attributes of data quality. You can see, is it accurate? Is it available, complete, fit for purpose? So take a look at these and get familiar with the different ways we think about the quality of data. So what are data management tasks? What is data management responsible for? Creating a clinical trials database involves the following tasks. First, there's document or records control. And document control is simply recording the receipt, storage, and status tracking of clinical trial documents, including case report forms, data queries, and study documentation such as correspondence or project-specific documents like the data management plan. Data entry refers to the process of transcribing or entering the data into the CDMS. Data review is the manual and programmatic checking done to identify discrepancies or errors in the database. Data updates are just modifications that you make to the data and/or the source document or case report form as you resolve your discrepancies or find new issues with the data. Quality control refers to a review of the database to ensure that it is accurate and it meets the acceptable error rate. It's different from quality assurance, which we'll talk about later in the course. Database locking. Essentially, when all data management tasks are complete and QCs determine the database has an acceptable error rate, the records are locked so that no changes can be made to the data. Why is this important? Well, because you're going to create a data set and provide it to the analysis team. Locking the database means that it can't be modified, and so therefore the data is stable. The data you're going to use for your analysis is going to stay stable and will not change. So we've talked about common data management tasks. Now we're going to look at it from a slightly different viewpoint, data management roles. And it's important to remember that tasks are going to be performed by individuals that are assigned to specific roles. But different organizations may assign and structure these roles in various ways based on issues such as workflow, headcount, or organizational structure. For example, some companies combine document control and data entry into one group. Others combine database programming and statistical programming into one group. But the most common data management roles are document and records control. And again, this can be integrated into data entry and data review, or it can exist as an independent function. Individuals performing this role, again, are going to record the receipt of study documents, track their status, and ensure that the documents are stored and later archived in compliance with industry regulations. Database programming is responsible for developing the database and creating supporting programs that are used by the data management team. Data entry can be performed at the clinical site, or it can be performed at a central data management center. Data entry is basically the process of transcribing the data from a source document or case report form and entering it into the CDMS. Data review is reviewing the data to look for clinical consistency or inconsistency, to look for discrepancies or trends in the data. In some cases, data review is being integrated with clinical site monitoring as part of a move towards what we call risk-based monitoring, or RBM. Quality control, again, is a role that can be integrated in with data entry or data review, or it can exist as a standalone role. And essentially what you're doing is looking at the database after all the cleaning has been done and checking the error rate so that you can make sure you have an acceptable error rate. So how do all of these people doing these roles and performing these tasks work together on a project? Well, this is a very simple data or project flow chart. Everything begins with the development of the protocol and ends with the generation of a study report. Once the protocol has been approved, it becomes the basis for an analysis plan. This is where the statistician outlines how they're going to analyze the data, and it tells you what they need to do to perform that analysis. The project team uses the protocol and the analysis plan to develop the case record form, or CRF, the database, and any project-specific plans for activities such as site monitoring, data entry, data review, and quality control. So keep in mind that the protocol and the analysis plan are going to drive the rest of the project flow. Once all the project plans are in place, the functional areas can start to work. Clinical is going to identify, recruit, and train investigators to run the trial. The investigators are going to recruit and enroll patients. Data management will create a database. Data is entered into the database. Data management and clinical will review all that data for discrepancies and trends. Discrepancies are resolved with the investigator. And once all the patients have completed the trial, data management is going to perform a quality control or QC check of the data. They're going to lock that database, and the statisticians can now analyze the data and generate a report. So that's a typical project flow. Now that you've listened to this PowerPoint lecture, you should go work through the rest of the Module 1 assignments. These include 2 short videos, some assigned reading in the textbook, as well as an excellent article by Peter Murata on data management and data quality best practices. You're also going to need to review the regulations and guidances that we have up. Let me know if you have trouble with any of the links. I look forward to reading your introductory post. Take care.